this, so in a minute it will be ready. I can tell you what we were talking about when we had to break off, and we can sort of catch up from there. I will start sort of acknowledging the fact that there's a, a, a bit of a gap here between the two images. But let me explain that. And but before I do, I'll tell you where we were. We were talking about SAI, and you'd mentioned that I think we looked it up, and 17 million tons of sulfur or something had been emitted from Pinatubo, and you were going to go on and claim that this shows that there's nothing to worry about.
Yeah.
So we can pick up that conversation there, and I'm not sure where we were going beyond that because we had sort of moved into talking about
we mentioned marine cloud brightening as well,
yes.
I remember, so we probably go there next.
We had talked, we were starting to talk about what interventions are the most promising, and you'd said marine cloud brightening, and we can go on from there from my point of view, unless you want to go in a different direction. It's fine with me.
No, that's good.
Okay. All right. So I will come back in.
Okay.
Hi.
Hi.
As you can see, Gwynne and I are wearing different clothes. And
Well, they got dirty, I mean.
That's because we had to interrupt our visit a few days ago and wait almost a week to resume it. And in the meantime, I guess we changed clothes.
Yeah.
And so we will, but we know what we were talking about. And I want to pursue that a little bit because Gwynne was reminding us that SAI can be sort of demonstrated by the effects of Pinatubo, which emitted something like 17 million tons of sulfur. With what effect?
Well, the one effect was that it's sulfur dioxide, actually, it's the gas. And it reflected a good deal of incoming sunlight, as sulfur dioxide does, but now it's coming in very large quantities from this volcano in the Philippines. And we had a global cooling, average global temperature down by almost 1 degree Celsius, tapering off over the next 2 years. So, yes, you can cool the climate. No, you don't need a volcano to do it. You could just go buy some sulfur dioxide. It's an industrial gas. First of all, you capture it from all the places that put it out as pollution, but you could also buy it, make it. And nobody died. There is no living things to speak of in the stratosphere, which is where it was. There were no grave effects in having 7 million tons of this stuff in the stratosphere for 2 years.
Yeah.
We would never be putting that much up, or at least not for a very long time. If we kept on doing this for half a century, yeah, we would be, but that's not what the idea is to do what they call peak shaving. Don't let the temperature go above a certain area while you frantically get the carbon dioxide out of the air and can stop geoengineering. So, but 17, that's a number way beyond what we would be doing if we began doing SAI. 1 billion would be more like it. Sorry, so am I saying billion or million here?
A million.
Million, sorry. 1 million tons, 2 million tons a year would be more like it when you start even smaller than that, but build up over a few years, watching carefully to make sure there are no surprises, but there shouldn't be because volcanoes do this at a much larger scale very abruptly. So there is your, it's not exactly a get out of jail free card, but when people realize they had a big problem, they also realize that if you needed it, you do have a quick solution. The slow solution, the final solution, the one that works permanently, is getting rid of emissions and not putting any more out. But even then, they realized that was, even then being, let's say, the late 90s, early zeros, they realized that getting rid of all the emissions in a world that is 80% powered by fossil fuel was going to take a while. They had no idea how long that was going to be because we haven't got rid of any of it yet. But they did understand you
Mhm.
needed a fallback. So, from the late 90s of the last century,
Mhm.
there were a number of people who were investigating the implications of doing what we know volcanoes do, but doing it obviously with aircraft or some other means. There were early open air experiments not using sulfur dioxide, but sort of trying. The British had a program in the around 28, 29, 20, 209, 20, 2009, um, to see what kind of what ways you could boast it into the stratosphere. And there at the time they were trying to do it with a large balloon and a 23-kilometer pipe, which seems to me
Yes,
probably
I
not the
remember
best
the
way of
talk
doing it.
about a big, like a drinking straw going into this.
That's right. Yeah, it was
Um,
called the Spice Program. And I've talked to some of the people who were involved in it. They never intended to do it. They were just, sort of investigating the technology mathematically. And they thought maybe at the end they'd, boost a couple of bathtubs full and spill it over a field in Norfolk in order to demonstrate that they had actually done some real experiment. But it was mostly mathematical studies and that sort of
Mhm.
thing. Um, so there was a lot of interest, but what began to happen right away was that some people in the scientific world and quite a lot of people outside the scientific world um, opposed even thinking about it because at
Mhm.
that time the assumption was cutting emissions was going to be easy. So don't distract us from this quick fix we're going to do, get switch 80% of the world's energy use over to non-fossil fuels in 10 years or 20 years. And so don't distract us with other things. They're just going to slow the process of the one technique that we know is permanent and works. Problem is that view that anything that distracts from emissions is negative, is slowing the process, has persisted, although the process never got started. We have never cut emissions.
Yeah.
And in the very best days, our
Mhm.
emissions that year dropped a bit, but they're always going up because it's cumulative.
Yeah.
And we are now, we were in 1990, we were at about 350 parts per million of carbon dioxide in the atmosphere. We are now at 425 parts a million. After 30 years of trying to do it,
Mhm.
we have lost that much ground.
Right.
So it's a bit unrealistic, I would say, at this point to take the position that we must not experiment with ways that keep the temperature from running completely out of control, because any experiments in SAI would detract, distract from the job of getting rid of the carbon dioxide. You could convince me of that if you're getting rid of a lot of the emissions now, and I don't want to slow your process down, but you haven't even got it started in 30 years. So don't tell me we shouldn't look for fallback positions when you are failing. So that's the
I
logic.
think of it as more than a fallback position. I think already it's going to be inevitable and necessary, completely essential. Let's get on with it. Let's find what we can do without,
Oh,
you
I do
know.
agree with you, but I'm taking a minimalist position here, if you don't mind.
Yeah,
But, the bottom line, yes, of course, it's 30 years later. You've used up your thinking about it time.
that's right. Mhm.
Um, but there we are. So that one occupied most of the space because it's the one that has, in a way, been pre-tested by nature.
Mhm.
Um, there are other gases or particles that you could put in the air that would also reflect sunlight in the stratosphere or even in the troposphere, in the bit we down where we breathe, the thicker atmosphere at the bottom. Um, but the focus is on sulfur dioxide because we know it works and we know it doesn't kill people. And yeah, there has been a bit of an issue with ozone holes possibly not shrinking so fast. I've talked to a lot of people about that. That's one of the arguments you often hear used against it. Um, and the problem is that um, there, while sulfur dioxide does not actually directly cause ozone, it kind of operates as a catalyst by which CFCs, those things that got banned in the
Oh,
1990s,
for the,
it's the CFCs that destroy the ozone, but they destroy it faster if there's a lot of sulfur dioxide in the air over the
Mhm.
poles.
I didn't know that. Okay.
That's how it works.
Mhm.
We've had a lot of attention on that over a period of about 40 years because we dealt with the ozone hole 40 years ago, and we dealt with it by cutting all of the CFC emissions, although we gave grandfathered them, so they only really started getting caught about 30, 20, 10 years ago in some cases. Um, but the ozone hole over the Arctic never grew at all, and the ozone hole over the Antarctic began to shrink.
Mhm.
And it's still shrinking. Um, the amount of ozone that was destroyed by Mount Pinatubo was not inconsiderable, but I mean, if you sort of scale it down to the kind of sulfur dioxide volumes we might be putting up to hold the temperature down, uh, the people I've spoken to who specialize in this stuff say, look, it would probably slow the healing. There would be some impact, but it wouldn't start it expanding again, the
Mhm.
ozone hole over the Antarctic. But it might, whereas we thought that we might be completely close the ozone hole by the 2040s, maybe you're thinking the 2060s. But it's not over any inhabited areas even now. So,
Mhm.
there's not even a lot of animals who are at risk from, the solar radiation that the ozone hole doesn't stop. So I don't think it's a big issue. The other issue you hear a lot about SAI, about putting sulfur dioxide in the atmosphere, is that it moves the rainfall around, and there will always be aggrieved parties who lost their rainfall. So therefore, you cannot do it because you're just creating opposition, and people's rainfall is being cut, and people are
Mhm.
starving, and so on. Actually, that problem was detected in the very early days by people doing mathematical studies. Nobody's putting stuff up in the air. It hasn't been done at all.
Mhm.
But the usual way that they do the climate studies, which is mathematically, um, when they simulated in a model putting sulfur dioxide in significant volumes into the air, what they found was that it did move the try it again, intertropical convergence zone, which is basically about 500 kilometers, 500 miles north and south of the equator. Used to be called the doldrums in the
Oh,
sailing
all
days.
right. Mhm.
It would move that up or down depending on how much off of the band where the rainfall is now. I mean, the
Sorry, you mean
doldrums.
expand the band or just
No,
move the
move
band?
it, move it, move
Move
it
it.
in latitude
Mhm.
so that, and this is particularly important for West Africa because the West African monsoon is actually a monsoon which is part of that extending over land, the doldrums that we used to talk about in the Atlantic Ocean. Very overcast, very rainy area with almost no wind. That's what the doldrums were. And over land, it delivers a lot of rainfall, which is why there is a band called the Sahel in
Oh,
West Africa which actually is in the middle of the Sahara but gets rainfall from that band of weather.
Uh-huh.
And it wouldn't disappear, but it would move south if you did a lot of geoengineering with solar SAI.
Mhm.
Um, because basically, well, it gets complicated. We don't need to go too far into it, but um, if you um, do a lot of geoengineering, you're going to get a lot more rainfall. Okay, because well, whether you go do the geoengineering or not, you're going to get the rainfall because it's warmer. There's more evaporation. But if you put the sulfur dioxide up there, you will also move that band, which carries the rainfall with it, south. Um, for reasons that the mathematics makes clear, but English language doesn't, So we just have to take that on faith. They found that if you put a lot of sulfur dioxide up there, you would move this band of rainfall, which includes several countries in West Africa and the Sahel, depending entirely on that rainfall for their agriculture. And suddenly the rain moves south and you're in the desert.
And
Well,
so
this was a problem.
the
It was
rain
seen
would
as
fall in the desert and not where the people are, and
yeah, yeah, it would
therefore
fall
we have
basically
to
instead
find
of
a way
falling
to
up in
feed the
yeah.
people.
Yeah, well, instead of falling up in Niger and southern Niger and Chad and
Mhm.
that band of countries in the Sahel, it would fall on northern Ghana, northern Nigeria, which have enough rainfall already, and the people up north are now in open desert and starving. That was the image we were given
Mhm.
already a bit dramatic, but plausible back then. So, what did they do? They went back and they did their mathematics and they said, well, if we want to put the rainfall back where it is, what do we have to do? And the answer was, what if we put enough up there to counter the whole warming for this year, we will move the band of rainfall. What would happen if we put half the enough up there to cancel half the warming? And the answer is the band stays where it is.
Okay.
So the consensus position, and this is now 7 or 8 years old, in the branch of the climate science business that actually pays attention to this stuff, and I've talked to all of them practically. Um, the consensus is that no, if you actually set out to counter the full warming for the year, and you're loading all that sulfur dioxide into the atmosphere, yeah, you are going to move that band and kill off agriculture in several West African countries. And that's definitely not a nice thing to do. If you only counter half the warming, the amount of sulfur dioxide you're putting up there will cause the normal amount of rainfall in the normal places.
Mhm.
Um, so no, you can't cancel all of the warming, but you can cancel half of it. Is
But then
canceling half of it
can't you,
good? Yes,
yes, but can't you do half of that and then go do some other technology?
exactly. Yeah, but that's the way you deal with that one, and that's the. I mean, in terms of the heavy lifting, that's the biggest thing you can do. Then you can start with things like marine cloud brightening.
Mhm.
Marine cloud brightening, as opposed to the stratospheric stuff, is right down on the ocean surface in what they call the boundary layer.
Mhm.
And you mustn't imagine people spraying stuff into the atmosphere to try to get it up into the clouds. You let convection do that. All
Mhm.
you do is with very specialized nozzles that will produce literally trillions of tiny bubbles of water a second. But you can get a trillion bubbles at that rate out of a bucket of water um, onto the sea surface or just above the sea surface.
Mhm.
Not very high push got tiny bubbles of water going through even tinier holes and being laid like a mat over the surface in the wake of the ship. And about half of that, particularly in the tropics, but it will happen anywhere, will then be lifted by convection,
Mhm.
by, the warming of the sun into an area, drying out and leaving only little morsels of salt from the salt water. The original water that sprayed boosts the bubbles up, and it boosts as it boosts them up, the bubbles dry into particles of salt, and the particles of salt are lifted into low-lying cloud layers. Which, and I've been in three navies, so I know about being at sea in the tropics, and I'll tell you, you're under this cloud almost all the time. It's a layer of, they call it marine stratocumulus cloud, a layer no more than 1 or 200 meters above sea level, so thin that you can usually see the sun through it. But if you thicken it up a little bit, you'll still be able to see the sun through it, but it will be reflecting much more sunlight because clouds do reflect sunlight up from their top surface. Okay. Um, and so the marine cloud brightening, the other big number in terms of holding temperature down, um, is basically thickening up marine cloud to reflect more sunlight using vessels with little sprayers. They're satellite controlled and unmanned. I mean, you don't want 100 of these. They're the size of large yachts, not
No,
Russian yachts.
we're going to put a photo of one on the back cover of Peace Magazine
Yeah.
because I interviewed Daniel Harrison, who's trying to save the Great Barrier Reef and he has a boat where you see the spray coming out the back. And
Yes.
I'm going to put that on the back cover of the magazine.
Excellent.
Hmm.
Okay, so anyway, there you have that. Um, by the way, while it works best in this low-lying layer of marine stratocumulus cloud, there's a Norwegian who did again the usual experiments not in computers with data rather than actually going out in a boat. Um, but she concluded that, in fact, you could do it over any part of the ocean, including parts that don't have cloud. You'll get less cooling in areas that don't have cloud, but even the invisible moisture, because when the little morsels of salt reach cloud level, they turn back into little bubbles of water. They're
Hmm.
the core around which water condenses into droplets. That's the whole point. Get the little bits of salt up there. I talked to one of
Which,
the
by the
people.
way, we should say it makes it whiter. That's the important thing.
Yeah,
The cloud becomes whiter.
the cloud becomes whiter. It reflects more sunlight, but in fact, the tiny bubble, drops of water that coalesce around the little salt particles that this process raises into the sky will themselves, without being part of a cloud, reflect sunlight too, so that you get
Mhm.
something like 30 to 50% of the effect when there's no cloud around at all.
Okay. Good.
And this has not been tried, none of this has been tried in open air because of this grim determination not to distract us from failing to do what we are, in fact, failing to do anyway. you know? So um, there's this one, which is Stephen Salter was the guy who did. He just died a
Yes.
couple of months ago. I saw him as recently as last year, and I hope the work he was doing is picked up by somebody because he started doing some very important
He's
work.
left money for them to continue. He has a workshop and everything. So.
I know about the workshop. Yeah, there's former students of his who actually
Mhm.
invited him to work in a building that they had bought. Um, So the work will continue, but it definitely needs vastly more attention because it is
Well, the problem is, as he put it to me, the nozzle isn't good enough yet.
no,
They need to perfect that nozzle because it's very important if you don't have the right kind of the right size of spray, it doesn't work, or it could even be harmful.
Yeah, that's right. But this is an engineering task, and Stevens Alder was an engineer. And actually, the reason how he got involved in this was that the guy whose idea it originally was phoned him up and said, "Can you make a nozzle?" He said, "Yes, of course I can." He still hadn't done it when he died, but he was definitely close. He thought.
Later.
Um, anyway, that's I mean the great virtue of that is that it is absolutely stoppable. If anything goes wrong, you just stop spraying.
Mm-hmm.
And all the side effects go away within a day if there are undesirable
Mm-hmm.
side effects, or if somebody downwind thinks that you caused them damage or whatever. Um, so those are the marine cloud brightening and stratospheric aerosol injection. They're the two big tools. There will be others. I could tell you one other that
Tell
I,
me,
I,
because
there's
I have about a dozen others, and I'll be interested in which one you
no,
think
no,
is
no, no. But
number
this is
three.
okay. Here is this is one that's um, basically one guy with an interesting idea. The problem that we really need this stuff for, I mean, we should be doing it in a sort of low key way right now, and cutting half the warming because we're already in the danger zone, and every temperature step up,
Mhm.
the risk of something really bad happening goes up. The
Right.
climate does not change smoothly. It changes in sudden lurches.
Mm-hmm.
And we are close to causing some of those lurches, but we don't know exactly where. So even now, holding down I'm going to wait till she gets the phone. Even now, the risk of sudden lurches upward in temperature exist, and we need to be capable of doing something about them. But none of the techniques that we're discussing here are easily deployed before you've done a lot of development on the vehicles you're using or the nozzles you're using and so on. And we're not there. If it happens tomorrow, and it could, I know people who think it's happening right now. Um, and we'll know about that by probably September, whether
Mm-hmm.
we are in the middle of that kind of lurch upwards right now. Some say yes, some say no. Most want to wait and see a bit more data, but it's frightening. We don't, not, none of those things, stratospheric aerosol injection, the marine cloud brightening, various other means that have been suggested, you couldn't get any of them up and running in 6 months. Most of them you couldn't get up and running in less than 6 years,
Mm-hmm.
and that would be a crash program. Um, and so I ran across this fellow called Bob Nelson, who is a retired engineer with the Caltech group, the Jet Propulsion Lab, JPL,
Mm-hmm.
who have done some extraordinary work over a period of about 40 or 50 years, and atmospheres on other planets and all that, which is what he used to do, and so on. And he showed up at the last but one of the semi-annual, every 2 years, conferences of geoengineers, climate scientists who are interested in geoengineering, with
The
this
one in
idea.
Italy? The one in
No,
Italy
not
or
the Italy one, the one in Maine 2 years previously, so 3 years back. Well, two and a bit years back now. Um, and he wanted them to look at this idea, and I regret to say everybody thought he doesn't know what he's talking about, and he's not even talking about the stratosphere. The guy's a freak or a nutcase, and he was treated with disrespect, frankly. I didn't disrespect him, and I talked to him then and subsequently. This is a man who is a senior research scientist at the JPL for 40 years. Come on, he's not a nutcase.
yeah.
And what the precise problem he wanted to address was, what if we suddenly needed to do this now without any of the
SAI or what? No.
more, not SAI. SAI, well, I mean, an atmospheric intervention, because
Okay.
we know damn
Anything.
well you're going to have,
Anything. Quick
you
help.
you you're going to have to build ships to do marine cloud brightening, and you're going to have to
Mhm.
design the nozzles. You're going to have to build aircraft to get up into the stratosphere to spray the sulfur dioxide. If you're going to do
Can't they
the
do it with existing airplanes?
no, well, no,
Really?
not really. 65,000 feet, and they tend to do altitudes still in feet. 65,000 feet is about the minimum at the equator to get the sulfur dioxide into the stratosphere. Spy planes fly that high. Enormous wings, spindly little bodies, very specialized engines because the air is very thin up there. Nobody has built a dump truck that could carry up sulfur dioxide to that altitude. It's not like it's technically impossible, it just hasn't been done. And airplanes do not appear out of nowhere. It's a development process and it takes time. I do know one scientist at the National Center for Atmospheric Study. That's National Center for Atmospheric Research, NCAR, in Boulder, Colorado, the U.S. government.
Mhm.
She's a German scientist who uh, thought, well, maybe what you could do is use a plane that's able to get up to 50 or 55,000 feet. We got lots of them. Private jets tend to fly at that altitude to stay out of the way of airliners.
Mhm.
Um, but if we could then put the sulfur dioxide in little particles of something that warms in the sun, and would then, by warming, create an upward current that would carry the sulfur dioxide the last 10 or 15,000 feet into the stratosphere. We can't go there, but we could put things in there with a warming, basically soot particles
Okay.
that would warm up, rise, and carry the sulfur dioxide with it the last 10 or 15,000 feet. So there's one emergency measure, but even that would take some convince. I'm not really sure that that would work.
Mhm.
She's not sure that would work. Um, but here's Bob Nelson's. Bob Nelson, his whole um, work was about working with reflectivity on planetary surfaces. 40 years of that at JPL.
Painting roads white?
Well, that sort of thing. But no, the painting roads white, first of all, if you ever driven on a road that's paved white, you need sunglasses in the dark. I mean, but beyond that, um, the the problem he had was existing technology, and we needed now. Okay, how would you
Okay.
deal with that? And he thought, well, actually, salt has about the same reflective, table salt has about the same reflective qualities as sulfur dioxide does. And all you're trying to do is bounce sunlight back into space, right? Sulfur dioxide does that, table salt does it. You can't put, say, table salt into the stratosphere because half of it is, in fact, chlorine, sodium chloride, right?
Right.
And chlorine is precisely the element that eats up the ozone.
Yeah.
So, so you can't put it in the stratosphere. But he thought, well, salt you can put in the troposphere down here, the bit where we breathe. I mean, we put it on our food. It's not a dangerous substance. So he thought, well, if you needed it tomorrow week, and you needed to use existing technology, you could just get a bunch of 747 freighters and distribute salt at about 30 or 40,000 feet, tiny particles of table salt, which in the interim would give you enough reflection to hold some temperature down. He got a bunch of people to do some studies on it, and he reckoned, 300 747, uh, the freighter version, jumbos, about 4 times a year, spreading table salt into the atmosphere, would reflect enough to give you 1 degree of cooling.
Oh,
And
all right.
it's not, that's, I mean, who knows? But it's
Yeah.
nice to have something in your back pocket that might work. And his task, which, if anybody knows where to get the answer to this, because he hadn't managed to get through to the right people, the question is, can you make the salt particles small enough that they don't immediately fall out of the air? I mean,
Hmm.
the size of the grains of table salt, well, table salt falls to the floor, right? So that's too heavy.
Grind it up. Why can't you grind it?
Yeah, I know, but I mean, yes, but it must retain its reflective possibilities.
So if you
You know,
grind it too small, it might not
it might
reflect it.
might lose them, but that's what you need to test. But the point is that this isn't 7 years of testing; it's about 3 weeks, if you can get somebody to do it. The planes are there,
Yeah.
table salt is there. I look. I don't know if this works. I said tell you
Okay,
this
let
more
me
as
let me top you. Okay.
okay.
There's somebody else, and I don't know anything about this. Just I dismiss this as implausible, but they say rice husks are white, and they float, and they will float on water indefinitely. And there's a hell of a lot of it because when you polish all the rice in China and India and all these places, you got a lot of rice husks. So if you sprinkle that on the oceans, you could cover all the oceans with floating white things that right there would reflect a lot of the light, back into space. Okay, game over.
Okay.
See if you can
Um,
top that one.
I was expecting something else because I know that the Center for Climate Repair in Cambridge and the Indian scientific body that does climate work cooperated in sprinkling husks in the Persian Gulf
Did
in
they?
an
I didn't know
experiment.
that.
Yeah, this was Hugh Hunt and people like that
Oh.
last year. But unfortunately, then a huge storm came along and sank it all. So, um, but they were actually using the husks to carry um, sort of a smorgasbord, but of things that would encourage algae to bloom in large quantities. So sort of, and the husk was just the little boat that they floated on. But if you get the algae coming along and starting to eat all this stuff, then you get the bloom and a huge amount of absorption of carbon dioxide, which may or may not sink to the bottom.
Right. Well, I noticed you haven't mentioned that the ocean. I usually it's iron they want to float, but not float. I mean, they sprinkle tiny bits of iron filings, and
Yeah.
this in certain areas of the ocean, it's not just iron. Sometimes it's potassium, or some places it's different things that there's a shortage of. But if they don't have enough of certain things, and iron is the main one, to uh, to grow, then the phytoplankton don't grow. And if you sprinkle it, then you can replenish and bloom your phytoplankton. It has a lot of effects. It exudes stuff that's good for the clouds. It feeds their fish, and it captures CO2 and can sink to the bottom of the ocean and be sequestered. So it's a sounds good. I mean, I'm up for examining it, but you didn't name
Well,
that.
I know I'm
Want
in
to give
favor of
us?
examining it, but it was very much in fashion 20 years ago, and a bunch of
Mhm.
entrepreneurs made fairly large amounts of money encouraging investment in it, and then folded their tents and went away. And nobody was able to prove that a significant amount of carbon dioxide was being absorbed by these plankton booms and wasn't eaten by fish and didn't sink to the bottom.
Hmm. But you wanted some
or
of
did
it.
sink at the
You
bottom,
know,
rather.
the only one I know that actually did it was a guy named Russ George, and he was hired by the Haida Indians in BC to enrich their haul of salmon. And so he did. He worked, and the next year they had a bumper crop of salmon. But the Canadian government came along and said, you can't do that again. So he's not been allowed to do it. I don't quite know why, but they thought that sounds like geoengineering, and we don't like things like that.
I don't think that, because it wasn't geoengineering, it was encouraging more fish. I
And he
mean,
got it.
the
He got it.
idea,
Mhm.
his idea was actually, let's have more fish and the plankton will be fish food. So we'll grow the plankton for that. He wasn't even attempting to measure whether the carbon dioxide was being absorbed and sequestered at the bottom.
Oh,
So he
yeah.
had, I mean, it was interesting. Maybe that's a good way to encourage more fish, but it's not about climate. There
Well,
were
there was a guy whose name I can't remember who is a real scientist and who was
Oh yeah,
doing,
no, there was people, there
yeah.
was real scientists talking about it, and there was entrepreneurs putting money into
Hmm.
throwing iron filings off the sterns of ships in
Hmm.
large quantities, and there were algal blooms, but there was almost no scientific work done. That's not really what most of them were there for.
Hmm.
This was 20 years ago. Now there is some reawakening interest in it, but the large questions remain. I mean, first of all, this is extreme intervention in the ocean. You are changing the character of the population of living things in the ocean quite, because I'm assuming you're not just doing it once a year like plankton blooms, you're doing it a lot more.
Hmm.
And so I'm sure the oceanographers and the fish population scientists would want a long, careful look at this before they encourage this to be done on a large scale continuously. But it might work. I'm not saying it won't. There's lots of things need to be looked at, but you got to get over the taboo, which is no longer formal, but it's still there, on looking into things that might allow us to hold the temperature down, bearing always in mind the purpose of doing this is to a restore comfort in some parts of the world, and the possibility of working outdoors in the daytime in other parts of the world. I mean, you get down towards India and places like that, and 20 more than half the population works outdoors, and they're getting 45 and 50-degree temperatures. I mean, holding that down would be a good idea on a food production level and on a human life protection level. Um, but I think that the taboo is still blocking a lot of research. There's more happening, but people are still. I mean, you look, for example, at David Keith, who has been one of the most earliest and most active investigators about stratospheric aerosol injection. He had government permission for tests of the equipment with which they would eventually test small amounts of a non chlorine based or a non sulfur dioxide based um, gas in the air, just to see how it, does it clump if you're moving at speed when it comes out of the airplane, all that sort of thing. And he was just using balloons with little propellers on them. Had government approval from the Swedish government. And then I know the name, but I'd get done for slander if I said it aloud. So a well known, if a bit niche, environmental group went and told the Laplanders, the indigenous people in northern Sweden, that this would be done at an altitude where their gods live and would disrupt the stability of nature, possibly the entire universe. And so the Aboriginals, to whom people must live, said, "No, we don't want this done." They had talked to the Keith and those people who talked to the Aboriginals first, but the other lot got to them. So they complained to the Swedish government. It was all cancelled. It was all shut down. And so not long after that, Harvard University, which is where Keith was working, started moving to close down his whole geoengineering enterprise there. We had about 10 people working there on it. I think, and I don't know, I know David, but I haven't asked him this question. But I think that's one of the main reasons he's just moved to the University of Chicago, which is going to support him in geoengineering work. But at Harvard, even Harvard, it's as easy to persuade Harvard professors as it is Laplanders.
I hate to agree with you. I can't disagree with you though. It's discouraging. You
Yeah.
Because in fact there is evidence that the more people know about geoengineering, the more favorable they are, at least to investigating it, if
Yeah.
not
Yeah.
deploying it. And of course, nobody would. It's so many different things anyway that it's not. You don't deploy it. You check out a whole bunch of different things that can be
Yes.
called geoengineering, and that's what we should be doing, all of them. Even the crazy ones. I'm in favor of the
Testing.
guy, yeah,
Yeah.
the guy with the salt, and the
Developing. Yeah.
people with the rice husks, and everything you want to check out. Let's do it.
Yeah. Well, given the
Something will work,
situation,
and we need it.
exactly.
Yeah.
I
Okay.
have to take.
Well, I hope your book does what I hope it's going to do and believe it's going to do. I think you're going to make a big splash. And I've only had time to read a tenth of it so far, but I've been totally wowed by it. So I've already picked a guy to do the review in the July issue. And
Well,
it's great. And by the way, if you can get me an ad, I'll put it in for free quickly.
I'll
And
mention it to somebody.
yeah. All right.
Yeah.
Wonderful to talk to you, Gwynne. I think I should let you go to the airport now. Is that what you're doing? You're
That's where I'm going.
going
Yeah.
back to England?
With one stop in Vancouver on the way.
All right. Have fun. I hope you've been having fun so far.
So far,
And
yes. Thank you very
yeah.
much, Brenda.
All right. It's been
Bye.
wonderful. Okay. Let's stay in touch and bless you. Thanks for everything. Okay.
Bye.
Bye.